We know that a system of linear equations is two or more linear what that use the same variables. What do you think it's going to be? Equations. A system of linear equations is two or more linear equations that use the same variables. Basically, two or more lines that are going to meet somewhere. Okay? The solution to a system of linear equations is the ordered pairs that makes all of the equations in the system true. If they don't meet, are they true? If you don't have an answer of an ordered pair and you plug it into an equation, does it make the equation true or false? If it doesn't work, it makes it false. So, we are going to use the graph at the right in order to be able to graph the following equations, and then we're going to figure something out. Okay? So, let's look at these equations. What do you know about the first one? What's its slope? Class, what's its slope? Class, 1/2. What's its y-intercept? How can we use our y-intercept and our slope in order to be able to graph this line? So, let's do Christopher. Where do I start? At 3. 3 where? 3 here or 3 here? Y-axis or x-axis? Y-axis. So this is my y-axis, so I need to start at 3. That means I need to put a point on point that is 0, 3. Then what do I do? Bentley. What? Why am I going to the right first? You could go up first, you could go right first, but what should we do just so that we can make sure everybody stays on the same page? Go up. Okay, so we're going to go up 1 over 2. Would we have gotten to the same spot if we would have done what Bentley said? Go to the right and then up 1. Yes. But it's different for different people. I don't want you to confuse them. Rise over run. Up 1 over 2. We're going up 1 over 2. Now we have this fancy line. I'm going to take my ruler and I'm just going to draw my straight line like this. Are we done with that line? Yes, we're done with that line. Okay, ready? Now we need to graph this line. Uh-oh. Y equals 2 times x. What's my slope? M equals 2. What's my B? If there's nothing there, we start at the origin. Nothing there. They're not giving us a starting point. So if we don't have a starting point, we start at the origin. And then from there, what are we going to do, Marley? Up to 1, 2 over 1. Up 2 over 1. Up 2 over 1. Okay, and so right now we are going to see that what's our core, where does it meet in the middle? Huh? 2, 4. So they do have a point in common. It is 2, 4. Do y'all agree? Everybody sees that they meet right there at 2, 4. Now we're going to check and see if it is actually a solution to both equations? Let's see how we check. We're going to write the first equation first. Y equals 1/2 times x plus 3. Sorry, wrote a funny number. Plus 3. So, we have this coordinate point. What is my y value of the coordinate point? 4. The only thing that's changing is the x and the y. What is my y or x coordinate of the coordinate point? Plus what? 3. Okay, let's do some math. What's 1 times 2? 2. And 2 divided by 2 is 1. So now we have 4 equals 1 plus 3. Does 4 equal 4? Yes. Okay, now we're going to check the other one. Y equals 2 times x. What's our y value, class? 4. What's my x value? 2. Does 4 equal 2 times 2, which is 4? Yes. So it checks for both. Do y'all see that? So if it is a solution, it's going to check in both equations. For the practice and the activities that we're going to be doing, you are required to check to see if it works for both. So using the problem above, describe in your own words how graphing equations can help you to find the solution to a system of equations. I'm going to give you 2 minutes. Go. Okay, so who would like to share their own words on how graphing equations can help you find the solution to a system of equations? Don't all raise your hand at the same time. Anybody? Share your thoughts. A penny for your thoughts? Anybody? I know you don't want me to call on y'all randomly. So, what we got? Erica, what'd you write? Okay. Okay, but do y'all think that graphing equations makes it easier to find where their solution is? What if we had to do it algebraically? What if we had to figure out what their solution was going to be because we had to solve for the x and y? So let me ask that question again. Ready? Everybody pay attention. If we had to solve systems of equations algebraically with numbers, that means that we need to figure out what the values of x and y are by solving the equation. How does graphing it make it different than solving algebraically? Marley?
I said by graphing equations you can visually see how the equation looks and intersects with the comparing line. By using the coordinate point where they intersect, it helps solving to see their solution.
That's beautiful. So she's basically saying you can use, it's a visual understanding if it's going to be an equation, if it's going to be a solution to the equation. Okay? Everybody turn a page. So we're going to graph the equations below to find a solution to the system of equations. And then we're going to use the check step to prove that the solution works in both equations. We're going to show all of our work. So I am going to let you tell me what to do. So y'all get to be in charge of the teacher. Yes? Just in terms of doing the problems. Yes? Okay. So who wants to tell me how to do number 3? Jordan. Start at 0, 3. Am I graphing the first line or the second line? The top line. Okay, so start at 3. Okay, what's my next step? Down 1. Which way am I going, left or right? 1, 2. Okay, thank you for giving me instructions. Okay, why did I have to go right again? What? It's negative. Okay, cool. Thank you for explaining that. Now I gotta do what? Like this? Okay, now what do I do? Draw a line. Okay, so I'm gonna take my ruler and I'm gonna do this. Is that right? Okay. Check my work. Make sure I'm doing it right. Now what? Okay, how do I do the next one? I'm going to start at the origin. Bentley shaking his head no. Start at what 5? 0, comma 5. Okay, so I'm going to start here. Now what do I do? Straight line up and down. Horizontally. Why? Anybody have something they can add to Jordan's? What you got, Joel? What's 0? There's no slope. Okay, so there's no slope, so that means that we can't have any kind of steepness of a line. So that means that we need to have a what kind of line? A horizontal line. So when you have an equation that says y equals, that means that our line is going to go straight across because all of the y values, how many of the y values? How many of the y values? All of the y values have to be what? What does it say? 5. All of the y values have to equal 5. So I'm going to draw a straight line like this. Okie dokie dokie. Here we go. Now what? Well, we got to figure out what? Okay, what's the point that intercepts? Oh. Huh? -4, comma. Okay, so y'all are saying -4, comma 5. Like that?
Yes.
Okay, now how do I check it? What do you mean plug it in?
Plug in your x and y values.
Into what?
Into the equation.
Into the equation. Okay, so what if I don't know which one's my x and my y? The first number is x. Second number is y. Okay, now what do I do? What's the fancy word that we use in math? Substitute. Okay, so how can I rewrite my equation? We have y equals -1/2 x plus 3. And then I have to substitute, right? 5 equals -1/2 times -4 over 1 plus 3. Okay, ready? Now I'm going to do math. I can use my calculator if I wanted to. Let me show you how to do that. -1 divided by 2. Enter. Times -4 divided by 1. What did I get? I got a positive 2. So 5 equals 2 plus 3. Yes or no? 5 equals 5. That's a right check. Now I got to do the other one, right? So 5, so it's y equals 5. What's the value of y? 5. So 5 equals 5. True or false? Okay, ready? Now you're going to tell me how to do number 5. Now we're going to do number 5. Oh, Marley's telling me I have to rearrange something. Y'all agree with her or no? Wait, what?
No.
I don't have to rearrange stuff?
Don't rearrange.
Yeah.
Oh, I thought we were on 4.
No, we're doing number 5. Sorry. Number 5, what do I have to do? I have to do what first before I do anything else? I have to what? Yeah, I have to change my equation from standard form to slope-intercept form. So this is not in slope-intercept form. It is in standard form. So what do we need to do? Somebody give me instructions. Add 6x where? To the other side. Okay, so I'm going to go over here just a little side so I can write this. So I'm going to add 6x to the other side. 6x. Now I get 2y equals 6x minus 8. Okay, what is my next step? Who agrees with Marley? I have to divide everything by 2. Okay? Now what? Okay, hold on, I'm confused.
Minus 4.
Why?
Because it's a negative.
But it's an 8 divided by 2.
But it's a negative.
Oh, there's a negative sign in front of it. Okay. So, now what? Can I graph it like this? Okay, so where do I start? Negative 4. On the y-axis or x-axis? Y-axis. So I'm going to start here. I'm starting here because this is my starting point, right? Okay, now what do I do? Who agrees with Marley? Up 3 over 1. 1, 2, 3 over 1. I feel like I'm not doing a good job of this. Okay, hold that thought. No, I did it crooked. Okay, now what do I do? I gotta go to the next one. Okay, what do I do?
0, 6.
I start at 0, 6. That's up here. Now what?
Go down 2 and right down 2.
Cooper, what do you think? Go down 2? Do I need to go to the right one or the left one, William? Well, I'm doing my slope. They told me to go down 2, but do I go to the right one or the left one? I couldn't hear you, I'm sorry. You said right? Okay, so if I go to the left though, then it's going to make the whole thing positive. Is the slope positive or negative? So we need a line that looks like this, right? So should I go to the right or should I go to the left? Right, sorry, right or left? I did it backwards. Right, okay. So down to right 1. I think I found our meeting point. What do y'all think? I think we found our meeting point. Here we go. What's our meeting point, class? 2, comma 2. Okay, now how do I check it? Substitution. Okay. Substitution. So I need to plug in a 2 for the y and a 2 for the what? Here we go. Y equals 3 times x minus 4. 2 equals 3 times 2 minus 4. 2 equals 6 minus 4. 2 equals 2. True or false? I did that fast because it's simple math. This is, we're multiplying and adding. Okay, y equals negative 2 times x plus 6. 2 equals negative 2 times 2 plus 6. 2 equals negative 4 plus 6. 2 equals 2. True or false? True. Okay. Let's do which one should we do next? 6. Okay, got it. Let's look at it. Tell me what to do. Okay, they're telling me I have to rearrange it. Who agrees? Okay, Abigail, what's my first step of rearranging? Add the x to the other side. Okay, now what? Now I have 4y equals x minus 4. Divide by 4. Who agrees with them? They're saying divide by 4. Okay. So what's my equation now? Good job. Minus what? What's negative 4 divided by 4? Okay, so this is my new equation. Now that he's organized. So now we're going to, can we graph, is this one okay?
Yeah.
That was really loud. Okay, so here we go. That's going to be the video. Yeah. Great stuff. Okay, what do I do first? How do I graph this? Amelie, how should I start? Well, do you want to graph the first one or the second one? The first equation or the second equation? Okay, so we're going to start on the second one. Where do I start? How do I start graphing this? This two? Yeah, okay, so am I going to go up 2 or down 2? Down 2. So I'm going to start at, what's my coordinate point? Negative 2. 0, comma, negative 2. Then what do I do, Amelie? Go down 1. Which way am I going over to? Back? Okay. Can we do it that way? What's another way we could do it? Up 1 over 2. It's the same thing because a negative and a negative is a positive, right? Okay, do we have our line now? Yes, we can graph our line. Jeez. Okay, next one. So we did this one. Now we gotta do the other one. Madison, where do I start? This is the equation we're graphing. It starts at negative 1. Good job. Okay, now what do I do? Which way? So we're going to go down 1 over 4. Down 1 this way 4. Okay. Down 1 over 1, 2, 3, 4. Y'all agree? Okay, so we have some agreeing, but Adeline's saying that we can also go up 1 over 1, 2, 3, 4. Are y'all okay with that? Okay, so ready? Let's go ahead and graph that. And what is the solution? Anybody? 4, comma 0. Y'all agree? So how do we check? We're going to substitute it. Somebody tell me how to do this. We'll do the first one first. So what do? 0 is where the what goes? The y, okay? 1 over 4 times 4 minus 1. Okay, so what's 1 times 4? 4. And what's 4 divided by 4? 1. 0 equals 1 minus 1. What's 1 minus 1?
0.
Does 0 equal 0? Yes. Okay, ready? Now what? Okay, 0 goes here equals 1 over 2 times 4 over 1 minus 2. 1 times 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. So 0 equals 2 minus 2. 0 equals 0. True? Okay. How are we doing? Where did we get lost, Amelie? Huh? I was just plugging in the values.
6 and 10
Where?
on the left.
No, it's 0 and 0. I just have a check mark, so it went up. Oh, this is a 1. Look, see? 1 minus 1. And I just wrote it with it. Okay, let's look at number 7. So, a parking garage A charges $3 per hour for parking. Parking garage B charges a fee of $2 plus $2 for parking per hour for parking. So, parking A, do they charge anything to actually park there? No, not to start, but they do charge per what? Hour. So what could that equation look like? Y equals what? Okay, y equals 3x. Are we okay with that? Because there's no starting point. They didn't give us anything. Then parking B charges a fee of $2 plus $2 per hour. So what would that equation look like? Would y'all agree? Okay, so I want you to graph the equations, and I want you to figure out what the system of equations means, like where they meet. And then I want us to try to figure out what does the solution mean in the context of the situation. So, in the context of the situation. So, I'm going to give you about 3 minutes. Go. Okay, if we graph each equation, we're going to start at what for the first equation? 0. We have to start at the origin and give us no starting point. So, that means that there's no beginning. We have to start at the middle. Then we're going to use the slope in our idea, which is the 3, but it's 3 over 1, so we're going to go up 3, right 1, because we're positive. So that means that slope dude has to be going up the mountain, not down it. That means that we are going to graph this line, just like this. Then we have our next line, which says that we're going to start at 2, and we're going to go up 1, 2, over 1, up 1, 2, over 1, up 1, 2, over 1. Okay, so then we have this other line that's very, very it's very, very close to the other line. They're almost kind of the same line, but they're not. They're just very similar. And we figure out that the solution is what? 2, 6. But then they ask, what does this mean in the context of the situation? So, think about it this way. What does the X stand for? The what? Per hour. So the hours that we are parking. What does the Y stand for? What does the Y mean? So Y equals 3 times what? What's the X mean? The hours, right? So what does the Y stand for? the total amount, right? So in context of the problem, what does it mean when the two graphs meet each other? Huh? So at 2 hours, both garages charge what? $6. So at 2 hours, both garages charge $6. So that means that whether you choose A or B, when you get to 2 hours, you're going to pay the same amount for both. Does that make sense? Okay. So I want you to take a moment. I want you to summarize today's lesson. So just kind of write something down of what you think today's lesson meant to you. Go.